This is lesson 16 from Ratios to Rates, homework help. Remember, you can use these videos as you need, so you might need it step by step. You might need it just to check in the answers and make sure you're on the right track, or you might need it just for one problem and then you're able to move off on your own. So just to recall from the lesson today, when we have something written like this, $15 per hour, that whole thing is called the rate. And it's a specific type of ratio. Then within the rate, there are two parts. There is the unit rate, which is simply the number that it correlates with that statement. And then there's the rate unit, which is the words that describe that part. So that's the rate unit. The whole thing is a rate, which is a specific type of ratio, and then each part of it is labeled unit rate or rate unit, which is the per hour. So in our first situation, Angela enjoys swimming and often swims at a steady pace to burn calories. At this pace, Angela can swim 1,700 meters in 40 minutes. What is Angela's unit rate? Remember, when we see that word unit, it has the base word uni in it. And we make a connection to unicorn, unibrow, unicycle. Those all mean one. So right now we know how far she can swim in 40 minutes. What we need to know is how far she can swim in 1 minute. So when I see 17,000 meters in 40 minutes, I do think of a ratio, 1,700 to 40. Several ways we can solve this to find how she can do for just one. We can find the value of that ratio, so we could reduce it from 1,700 over 40 to something over 1 minute. We could do our double V diagram and figure out how many meters she can go in 1 minute. Probably a tape diagram would be tough just because how big our numbers are. So those would be my two go-tos. So if I'm using the double V diagram, I would ask myself, what did I do to 40 to get to 1? Well, since it was smaller, I know that I probably divided by something. 40 divided by what equals 1? Hopefully you know your patterns, and anytime a number is divided by itself, you get 1. So if I divided the minutes by 40, I also have to divide her meters by 40. I'm always going to take, or I try more often now to take the opportunity to practice some number bond use so I can do this in my head instead of somewhere else. So if I have 1,700, how much of that could I pull out? Would be easy to divide by 40. So immediately I think of 4 and 17. Well, to divide 4 and 17, I would use 16. So that's 1,600. And then how much is left over to get me to 1,700? That would be 100. So now 1,600 divided by 40 would be 4. I'm trying to figure out my zeros here. I know it's 4. And then there's a 0 there, there's a 0 there. So I think it would be 40. Again, I'm going to see the reasonableness of that. If I have 40 groups of 40, that would be 4 times 4 is 16, 2 zeros, 2 zeros, 2 zeros. So yes, that makes sense. So 1,600 divided by 40 is 40. 100 divided by 40, again, I'm going to simplify it, divide it by 10 first. Now I'm dealing with 10 and 4. And so that one's kind of tricky. So what can I divide 10 into that would be easy? Ooh, what about 8? 8 and 2 would be a good way to break up 10. So then I'm breaking that into 8 divided by 4 is 2. And again, I took off the zeros, so that's why I know I'm only dealing with 4 here. So 8 divided by 4 is 2. 2 divided by 4 is a little trickier. But if I think about money and I had $2 and I divided it into 4, or I had 2 cookies and I needed to make 4 pieces, each person would get a half. So I think my answer is 42 and a half. So I'm going to go 42 42.5. If you don't like that method, you can always do 1,700 divided by 40. Again, I could make it simple early and take off a 0 here, take off a 0 here. So now I have 170 divided by 4. How many groups of 4 can I make out of 1? 0. How many out of 17? 4. 4 times 4 is 16. I subtract, bring down. I have 10. 4, how many groups of 4 can I make out of 10? 2. 2 times 4 is 8. Subtract. 10 minus 8 is 2. Now what am I going to do? I can't have a remainder of 2 meters. She has to be able to swim those. So I remember when I'm dealing with money, all whole numbers have a decimal at the end of them. So I could put a decimal there, and then I have add a 0. I remember that silly song. Straight up now tell me that is where the decimal goes. Yeah, yeah, yeah. Now we're ready to have some fun. The kids are looking at me like I'm strange because they love my singing voice. I know that's why. So now I have not 2 wholes, but what if I thought of it as 20 hundredths? Not hundredths, tenths. 20 tenths. If I have 20 tenths, and I'm just picturing them like this, I have 20 of those. Can I divide those into 4 groups? Yes, I could divide those by 5 in each group. And there's my 42.5. Same thing goes here. If I was using this method, what did I do to 40? Did simplify it to 1, divide by 40. What do I do up here? Divide by 40. 42.5. So the question is, what is her unit rate? Remember, unit rate is just the number. So her unit rate would be 42.5. So I might circle that so that I can recognize that that's my answer there. So now it says, what is the rate unit? In this case, the rate unit would be meters per minute. So here I would write meters per minute. All right, moving on to the back. Remember, it's always good to read the lesson summary. So a rate is a quantity that describes a ratio relationship between 2 types of quantities. So we have rate, and it's describing the ratio relationship between 2 types of quantities. And quantities just mean 2 types of numbers. So like here, we had meters, which is a measurement, and we had minutes, which is a time. They're both quantities. They both have numbers, but they're different types of quantities. So we have that rate. Then it says, for example, 15 miles per hour is a rate that describes a ratio relationship between hours and miles. Those are those 2 quantities. If an object is traveling at a constant 15 miles per hour, then after 1 hour, it has gone 15 miles. After 2 hours, it has gone 30 miles. After 3 hours, it has gone 45 miles, and so on. Those remind me of data points that might be in a table. When a rate is written as a measurement, the unit rate is the measure, so the numerical part of the measurement. So the unit rate is the numerical part of the measurement. For example, when the rate of speed of an object is written as the measurement 15 miles per hour, 15 is the unit rate. The unit of measurement is miles per hour. So the unit of measurement, the unit rate, miles per hour. Miles per hour. So let's look at our problem set here. The Scott family is trying to save money, as much money as possible. One way to cut back on the money they spend is by finding deals while grocery shopping. However, the Scott family needs help determining which stores have the better deals. Well, let's help out that Scott family so they can save money. At Grocery Mart, strawberries cost $2.99 for 2 pounds. And at Baldwin Hills Market, strawberries are $3.99 for 3 pounds. What is the unit price of strawberries at each grocery store? If necessary, round to the nearest penny. So this kind of reminds me of some of those texting problems we've had, or the commercial to Showtime problem that we had, that we really need. We can't compare the 2 pounds and the 3 pounds because it's different poundage. So we need to get it to be equal, or like I say, apples to apples. So workspace for 1A, finding the unit price. Unit, how much it costs for one item. So in this case, it's $2.99 for 2 pounds, but I don't want 2 pounds, I want only 1 pound. So right here, this is where I would put 1 pound. So if you can go from here and figure out how much those strawberries cost, try that on your own. If you can't, stick with me. So right here, I noticed that, what did I do to 2 to get to 1? Well, it got smaller, so I took it in half, or I divided it by 2. Half of the group is the same as dividing by 2. So now, since I did that to this part of my ratio, to keep it equivalent, I have to do the exact same thing to the other part of the ratio. So I need to take that and divide it by 2. So now, I'm going to try maybe some of my number bonds. If I have $2, I can split that pretty easily. That's going to be $1 and some cents. Now 99 is going to be tricky, but if I start with just, so if I'm over here at 99 cents and I break it into 90 cents and 9 cents and divide 90 cents by 2, that would be 45, right? Yeah, 45. 45 plus 40, 40 and 40 is 85, and 5 is 10, so that would be 90. 9 cents doesn't divide very nicely by 2, but what if I did 8 cents and 1 cent? 8 cents divided by 2 would be 4 cents. Then I would only have 1 penny left, and I can't really divide up 1 penny by 2, so it would be 4.5 pennies. It said I needed to round to the nearest penny, so 4.5 is going to make me round it up to 5. So I think this should be $1, and then I have 45 cents here, 4 cents here, but I'm going to round it up by 1, so 5 cents. I think it rounds up to $1.50 per pound. So the unit price of the strawberries is, that's just the number part, so that's going to be $1.50 for A. And then B, I'm going to do the same process, except I have $3.99 for 3 pounds. I, again, need to get it down to unit price, so how much it is per pound. So that would be 1. Again, if you think you can solve this on your own, go ahead and do it, and then check back to see if you got it correct. If not, 3 divided by 3 gets me 1. So I know I need to do the same thing here and divide it by 3. Now this one looks like it's going to be easy to divide, because $3 divided by 3 would be $1. 99 or 9 would be 3. 99 would be 33. So I think this is $1.33 per pound. So the unit price would be $1.33. So now, if the Scott family wanted to save money, where should they go to buy the strawberries? Why? So which store would you rather buy the exact same amount of strawberries? Would you want to buy strawberries for $1.50 per pound, or would you want to spend $1.33 per pound? So think about that, and then put your answer in here to decide which one would help them to save money. Make sure that you say where they should go to buy their stuff, Grocery Mart or Baldwin Hills, and then explain to me why. So this one looks very similar to these, so after this explanation, hopefully you can use the same process to solve B and bring that back to class.